So I try to talk about this in a quick fashion, so we can record some time, about a proposal to build a trusted ledger over an unconventional medium that is a social network, in this case Twitter, just Twitter. But we can imagine other social networks. So there is no the need to consider Twitter. We have. This is the result of two papers, so I just present on behalf of the other authors. So, the motivations from which we start is that blockchain, Bitcoin blockchain, but also other blockchains are not suitable for some kind of applications. So, as we have seen before, one problem is the problem of the fee. So if you want to publish a transaction in blockchain, you want to hope that the transaction will be verified soon, we have to pay a fee, non-negligible fee. We've seen that the price is increasing. So if we have small value transactions, so this is a problem if you want to use public blockchain. And another problem is the time for the verification. So we have to wait 10 minutes, for example, in Bitcoin, 15 seconds in Ethereum, for example, but sometimes we need rapid verification. And there are other problems. For example, the capability of the endpoints of the peer-to-peer network in terms of computational power, in terms of storage power, in terms of bandwidth, traffic that they can exchange in upload and download. So for example, if you consider IoT applications and you want to have that the devices are really participating in the blockchain, so they don't delegate to other nodes, because this is possible, so they cannot in general, because they don't have the cryptographic capabilities, they don't have the traffic power bandwidth to do this, and they don't have the storage space to store even what they need to be lightweight nodes of the blockchain. So in this case, the question we pose is this: can we implement a public ledger over a social network? So to overcome the bad drawbacks, and obviously we lose some feature of the blockchain, the real blockchain, and we have to pay some price. So we have to understand if this price is acceptable and in which context. So this protocol is called Tweet chain. So the answer is this, yes. We try to answer yes, it's possible over Twitter. And we have to reinvent a consensus protocol, and we just use tweets to publish transactions. And roughly speaking, the consensus is based on the replication in the community of the tweet, of the transactions. So transaction confirmation tweets from the community form a mesh chain. So and this mesh chain makes it impossible for anyone to forge, to delete, to include invalid transactions. And the important thing is that this is true also for Twitter. So Twitter just has the role, the current role to play, to publish the tweet as today. So Twitter does not participate in the protocol. It's just the medium. And from a conceptual point of view, the protocol is truly peer-to-peer. So there is no super node. So every node is equal to the other. And the role, I say, Twitter is not a TTP, and no peer-to-peer features are needed for the devices, for the client that want to join this community. So what can do? Twitter could stop the entire community. Twitter could not just drop a transaction, for example, because of the mesh chain, but could, in principle, say, okay, since from now on, the community is down. So this is probably a little plausible, and anyway, we think that this kind of solution is not suitable for critical application like cryptocurrencies, but is suitable for non-critical application, for example, crowdsourcing applications, some kind of IT solutions. Where we want small value transaction, for example, requiring fast validation. For tweet chain, we measured, we estimated just 30 seconds for the validation and 6 seconds for the transaction publication. No local storage, because everything is stored in Twitter, in the cloud of Twitter. No effort for low computational power endpoints, no cryptographic capabilities, no peer-to-peer download, upload traffic. So just a very, very quick overview of over the technical detail. The protocol is very simple, so I think it's very understandable just to see at the slide what do we need. What we need about for this protocol, we need a social network like Twitter, able to offering posting of tweets of some message, small message, for example, of offering the following property and the feature of searching in an efficient way, for example, by hashtag in the case of Twitter. We have a welcome profile W that is implemented sort of yellow page, and to participate, this is the prerequisite to participate to the tweet chain community. A user just has to be able to build a hash chain starting from a secret, for example, using any collision-resistant hash, cryptographic hash like SHA. And we assume that there is a sufficient number of members. There are the parameters there. They are related to some assumption that we will see later. So the first step is the registration. To join the protocol, the community, the user has to publish a tweet referring to the yellow page profile, including I don't know what is the pointer. Includes the first element of the hash chain, and this is done to prove that this tweet can be generated only by the legitimate owner of the profile. And this tweet is replaced by the W profile by using the current value of its hash chain. This point X, that is the user, generates a random set of users registered. So if you look at the timeline of W, you can choose randomly X T. I don't know. I don't remember the number. a suitable number of users that are the follower. They have to replay, confirm by retweet any transaction tweet of the single member. So the way to generate this set of random users from the timetable of from the timeline of the profile W is standard. So they can use a pseudo random number generator starting from the ID of the user, and this way we have that each transaction that has this form is published in the timeline of the user. This is the element of the dash chain. This is the input transaction that is a ID of another tweet, so of another transaction. And this is the reference to the recipient of the transaction. And the content is text, just the text allowed by Twitter now is more than before. And what happened is that any set of the follower chosen in the registration phase, if they agree the protocol, they have to replace, they have to publish, reproduce the confirmation tweet of this kind, so referring to the original transaction with the with inclusion of the hash chain element of the corresponding user. So this way, we obtain a mesh chain, and it's possible to understand that it's not possible for anyone to drop any element of this hash chain, because otherwise this can be verified, and the verification look for the existence of a sufficient number of confirmations. So the approach, the consensus is based on a crowd-based assumption. So if there is at least T users that confirm the transaction, so the transaction is true, because any confirmation is based on the verification, like in blockchain, of the validity of the transaction, so no double spending, the right ownership of the money. For example, if it's a money of the right. Okay. And we have a number of assumptions to prove, to argument the security. So the transaction is that Twitter is up, running, that the adversary cannot change information on the network page of any user, so the profile are protected. So, for example, they use double-factor authentication, something like that. The cryptographic hash function is robust, and the adversary cannot access secret information of users. And among X verifiers, at most a percentual of them may not collaborate by executing correctly the verification protocol, because if they don't collaborate, obviously the protocol fails. And at most, T users can maliciously collude to break the security property. This is the common non-collusion assumption used in crowd-based systems. So this T is a parameter of the system, and it's sufficient to fix a T sufficiently large in such a way that it's improbable that the number of confirmation is not sufficient to prove the transaction. So we have formalized the security properties in terms of transaction authenticity, transaction integrity, the possible attacks, and non-reputational transactions. So as conclusion, I try to quickly show you an overview about this protocol that is in some sense revolutionary because we try to change point of view. So we need the public ledger. We want to exploit the power of public ledger, but we don't have we don't pay the price of the problem of, introduced by the proof of work. The problem introduced by because we don't have to compute anything here, just the replication tweet give us the trustworthiness of the transaction itself, and we don't need any special features for the clients, so no peer-to-peer features and no storage and etc. So in some sense we can see this like a lightweight public ledger, and if you want to think of the case of down of the system, of Twitter could be also down, we could increase the dependability of the system also by consider multi-social network approach. So we can replicate over different social network the same system. So we can think of an application that allow to publish the same post over different social network, and the system could operate in a multi-social network fashion. So we plan to extend, formalize, and prove the security in a more formal way, and that's all. Thank you very much for the attention.